Soldiers and Marines deployed in Iraq and Afghanistan routinely carry between 60 and 100 pounds of gear during their missions, which often results in muscle strain, bone spurs, and degenerative arthritis. It's for this purpose FoVI3D is developing an autonomous personal carry mule, or PCM, to preserve the health and well-being of soldiers and first responders. Aside from carrying heavy payloads, the main function of an autonomous PCM is 3D navigation of single-track rural trails or urban paths. This is a complicated process in off-road terrain which does not have obvious navigation markers and is ripe with obstacles such as rocks, roots, water, mud, and sand. As a computer vision problem, robotic navigation can require large compute resources which can quickly drain a PCM's battery. Both payload and compute requirements burden the onboard battery and are the focus of FoVI3D's PCM development. Our goal is to make a powerful, silent, and energy-efficient off-road capable autonomous PCM. FoVI3D's advancement of autonomous PCMs comes from our human-machine teaming algorithm called Pathfinder. Pathfinder is being developed in 2 phases. Currently underway, Phase 1 utilizes FoVI3D's development PCM, CRO Mark I rover, to build the image databases and train the convolutional neural networks necessary for our AI systems to perform image segmentation and recognition. Phase 2 will utilize these neural networks to develop off-road follow and retrieve functionality, where a PCM can construct a high-fidelity 3D mental model of a path by following a human lead. Once the path has been traversed and stored, that PCM can then navigate back and forth autonomously. To date, in Phase 1 development, the CRO Mark I rover has collected over 16 kilometers of single-track video imagery, populating a database of over 220,000 images of forested, grassy plain, and rocky single-track trail and path imagery. TensorFlow is used on this trail image database to train the convolutional neural networks to classify and segment trail and path subimage regions from non-trail and non-path subimage regions. FoVI3D's unique neural network training process first uses desktop GPUs to identify navigable areas within a trail path image, which is a time-consuming process. These trained neural networks are then used to train a second, much more efficient neural network classifier, well suited for smaller, low-power processors, allowing for longer battery life, and smaller, less expensive, more mobile robotic systems. The end objective of FoVI3D's autonomous trail path finding research is to support the development of a robotic mule that's low-cost, medium-scale, heavy-duty, silent, all-terrain, semi-autonomous, and above all, relieves the soldiers and first responders of the need to carry much of their personal gear.